So in the circuits that you've seen so far, you will have two types, yeah? Series and parallel.
Yeah.
In the series circuit, the important rule about it, the property, is that the current has only one path.
Yeah. And parallel has.
And in parallel, current has multiple paths, more than one in any case. And that actually changes the entire behavior of the circuit. All right? So let's start with series. So, for example, you can have, let me do that here actually, some sort of a cell, power source, etc. All right? And let's say you have two resistors.
Yeah.
Rough diagram. Okay. So that's your positive, that's your negative. All right. And whatever the voltage is. All right. And the current is going to follow that way. Symbol for current, I. All right. And then you have, let's say, resistor 1, resistor 2. All right. As you can see, there is only one path, and you have to go through the resistors one after another. All right.
Yeah.
So there's no choice for the current to go any other direction or anything like that. Okay. So the main properties are total resistance equals sum of individual resistors. Okay, so if you add more resistors to a series circuit, the overall resistance of the circuit will increase, right? And the second effect of that is that the current will decrease if the voltage remains the same. So for the same power source, battery, whatever you want to call it, if you increase the resistance, the current will decrease. All right, does that make sense so far?
Yeah.
All right, so have that, fine. And have you done Ohm's law?
So not yet.
All right, the one rule that comes along, and I will actually write that up here, you may not have seen it yet, but you should have done, is V, voltage, equals current in the circuit times the resistance of the circuit. Okay, we'll come back to this when we need it.
Yeah.
And there's a little bit more detail to go with that. All right, fine. And the other rule with series circuit is that the current is same at all points in the circuit. All right. So in other words, if you have I1 here, it must be I1 there. One simply referring to, that's whatever the current is, and I1 there, etc. So it's the same current all the way through. All right. Current does not vary at different points in the circuit. All right. Any questions? All right. Then the third rule, okay, is that the potential difference, okay, across components. The potential difference, and you may sometimes want to call it voltage, is shared across components. components. And I'll give you an example on that. All right. So in this circuit, let's imagine this voltage thing here is 6 volts.
Yeah.
Okay. And the resistance 1, R1, is 10 ohms. And R2 is 20 ohms. All right. What happens is that the voltage is going to be shared, right, in proportion to the resistance. And the example is this. So, for example, using Ohm's law, V equals IR, all right?
Yeah.
What is the total resistance of that circuit there?
30.
It is, right? So we know, using V equals IR, that 6 volts equals the current times the total resistance, which is your 10 plus 20. All right? So effectively 30. All right?
Yeah.
Rearranging that, we've got current is 6 volts divided by 30 ohms, and that's 0.2 amps. All right?
Yeah.
Now we can use this, Ohm's law, right, for each component. So for R1, right, the voltage equals the current times the resistance, all right, which is 10.
Yeah.
Okay, so the potential difference across R1 is effectively 2 volts, all right? And then for R2, the voltage, again, same current, that's the important thing, all right, must note that, times 20, 4 volts, yeah? And therefore, look, the total is 6 volts.
Yeah.
All right. The ratio, the way to work it out, is that for R1, right, it's 10 volts out of a total of 30. All right.
Yeah.
Times the total voltage of the circuit, which is 6. So it's 1/3 of 6.
Yeah.
Again, 2 volts. All right. And for R2, just to demonstrate the whole relationship of it, equals 4 volts. So do you see? It's the same, right?
Yeah.
Now, what I've done here, right, the important thing is I've actually used a calculation here. So whatever resistance you're talking about in the circuit, you put that over R1 plus R2, meaning the particular resistance over the total resistance.
So would it be 10/30?
Yeah, which is exactly that.
Yeah.
Do you see? That's how we got the 10/30. So that tells you the fraction of total voltage that changes across R1. All right? And it's the same for R2. If you do the same thing, it'll be R2 over the total. So that'd be 20/30. Like that. All right? So you can do one of two things in questions. You might work out the total and then work out the current and do it individually, like we've done it in the first part. right? Or
Yeah.
you could use the fraction method and do it like this. Either of those is valid, depending on what information the question gives you to start with.
Yeah.
All right? Does that make any sense? All of that?
Kinda, yeah.
All right. Any questions? Anything that you're not sure about?
Not really.
Okay. It's a question of actually remembering the stuff. I'll give you some questions in a minute and you can work through some, all right? Okay. So the next one is parallel. All right. Oh, one rule for this. I should come back to this and just say, bear with me. So this one, R1 will have a V1 associated with it, which is what we worked out just below. It's like 2 volts.
Yeah.
All right. And V2 for R2, that one equals 2 volts. That one equals 4 volts. All right.
Yeah.
So the sum of the individual voltages will be the same as the total voltage into the circuit.
Yeah.
Okay? Has your teacher mentioned anything about electromotive force, EMF?
No.
No? All right. We'll use it when we need to. Okay. So that's all fine. And then for parallel circuits, okay? A typical parallel circuit, let's say with a couple of branches. Okay, so okay, so again we have a voltage into the circuit. Usually we denote that by E, right? Your school may or may not. And let's call it 6 volts for the moment. Okay. And then again, you've got R1, you've got R2, all right?
Yeah.
And they're going to have, each one is going to have a particular voltage, all right? V1, V2 associated with it, all right? Now, here's the difference, right, between parallel and series, is that the current in the total of the circuit, so here, coming out of the battery or the power source, all right? When it gets to this point here, all right, let's call it P, it's going to split because it has 2 paths that it can follow, all right? So you're going to get one bit, I'll go to red here. One bit is going to go that way. So I'm going to call that, you know what, I really should change that. Let's call that I1, and I'm going to change this one to, whoops. I'm going to change that to I total. All right? So that's the total current in the circuit. And this one in the first branch is I1, flowing through resistor 1. Okay? You follow so far? And this one here is going to be I2, and that's going to flow through resistor 2. All right? So each branch can have a different current according to whatever resistor they have. All right? And then they add up again and become I total in the rest of the circuit. Okay?
Yeah.
So at point Q, they add up. So at P, current splits. And at Q, current adds together again, for want of a better term. Okay? Like that. So now the properties of a parallel circuit here. Okay? So first thing, current splits across branches. All right. Then it will always, right? Current always chooses path of least resistance. All right. So what that means is more current in branch with lower resistance. Okay, so if we were to take that arrangement and again have our 10 and 20 resistors, you'll have more current flowing through the 10 than you would in the 20.
Yeah.
Okay, and the next rule, and this is the really important one, in this arrangement between P and Q, and I'll put this in red because this is fundamentally important. Between P and Q, voltage and therefore potential difference is same. All right. Now, watch this thing. Remember in the series circuit we had earlier, the voltage gets split across the components, the two resistors. All right.
Yeah.
But in a parallel circuit, because one of the rules about circuits is that the voltage difference, the potential difference between any 2 points in the circuit, right? So between, let's change that word, between a pair of points on the circuit, all right? Doesn't matter what path you take, the potential difference between those 2 points remains the same always, okay? So if you look at P and Q there, whether I go from P to Q through resistor 1, all right, or I go around resistor 2, the voltages between those 2 points, P and Q, will remain the same. All right? Okay. And that includes this. Okay? So what that means is the voltage in this example V1, which is the voltage across R1, is the same as V2, which is the same as your power input. I keep saying power, but it's the electromotive force, right? Which in this case is your 6 volts. Yeah?
Yeah.
So your input. All right. And if we know that voltage and we know the resistor, right, we can now use V equals IR again to work out the current in each one. All right. So for R1, the voltage equals that. No, hang on, let's go with that. So that's 6 equals the current, I1, times the resistor, okay, which was 10. Okay? Rearranging that, I1 therefore must be 6 divided by 10. Yes, absolutely. 0.6 amps. All right?
Yeah.
And then for R2, again, just using the same calculation, 6 volts again.
So 6 divided by 20.
Yes. 6 over 20, and that's going to be 0.3.
Yeah.
All right? And therefore, we can work out the total current equals 0.6 plus 0.3,
No,
therefore
9.9.
0.9 amps.
Yeah.
All right? it's actually, look, with the same resistors as we had before in the series, arranging them in a parallel fashion actually gives us a higher current. All right? So, larger current than in series with the same two resistors. Okay? And if there's a larger current, it means that overall resistance of the circuit is lower. Okay? So this is the sort of thing that you get in a question to compare series and parallel. All right? Parallel circuits lower the resistance in general. Okay? That's what we've just demonstrated. All right? You don't, in GCSE, you don't have to work out the overall, the formula for parallel resistance. You don't have to learn, but we can work out the overall resistance by using, again, the total current and the voltage that we know, all right? 6 volts, 0.9 amps is the current, and this would be the total resistance of the circuit, all right? And you're going to have to bung that in a calculator for me. You got a calculator?
A calculator. So,
I'll find one. Hang on. 1 second. 6 divided by 0.9. And it comes to RT equals 6.67 ohms. Right? Now, this is a really important result. Okay, I need you to understand this one thoroughly. In a series circuit, the resistance of those two resistors was 30 ohms, right? Because you had to go through them one after another. But in a parallel circuit, right, the overall total resistance of a parallel circuit is lower than lowest resistor.
yeah.
Oh, resistor. Okay?
Yeah.
So the more branches you add,
Yeah.
even though you're adding another resistor, the more branches you have, the lower the resistance.
Yeah.
Okay? Does that make sense through what we've done? Yeah?
Yeah.
So coming back to the overall thing, all right? In series circuits,
Yeah.
the total voltage is split between the resistors or whatever components you have. So you might have a lamp in there, right, with a resistance. But the current remains the same. And the total resistance is the sum of all the individual resistors.
Yeah.
Okay? In a parallel circuit, the voltage across the components, if they're arranged in this diagram the way it's done here, the voltage across the components is the same, the potential difference, all right? That remains the same, but the current will split. So each branch will have a different current if the resistors are different, okay? And the overall resistance of the whole circuit, all right, is lower than whatever the smallest resistor is. And if you add more branches, it'll lower the resistance even more.
Yeah.
Okay? And the currents in the branches add up to the total current in the circuit. All right? Does all of that sort of so far makes sense.
Yeah.
All right. I will post that, and you're welcome to go through that, watch it again, and see what we've done. All right.
Yeah.
But those are the basic facts you need to know for the two types of circuit. All right.
Yeah.
Okay. Cool. I'll pause there.